Let's talk about ordinary annuity. It is an annuity which cash or payment flows at the end of the period. For you to easily define ordinary annuity, here are some scenarios showing ordinary annuity in real-life situations.
Rajay has a daughter named Sarah, 12 years old, kid living in a province. Like other parents, he also wants to give his daughter a birthday party. He wants to join his daughter's debut since Sarah, 12 years old today. After 6 years, she became 18. Rajay want to save money for his daughter's upcoming birthday party.
Yung dalawang mag-asawa para makadagdag sa
How's my daughter? What if I call her?
financial flow sa mga gastusin natin. Why not coconut, diba?
Oh, Father is calling. Hi, Father. How are you?
I'm fine, my daughter. I called because I want to know if you're okay.
I'm fine here. Don't worry about it.
By the way, Syra, I just want to tell you how sorry I am because I cannot go to your birthday party. But don't worry, I will send and give you money.
But why, Father? You always never come when it's my birthday. You know, Dad, one of my wish for my debut is that you are my last dance.
Don't worry, Syra. I will make sure that I will do anything to go to your special celebration. Bye for a while, Syra. I need to do anything.
Hi! Hey, Francis, I'm happy that you're here and visit me. Have a seat. Thank you. How are you, my friend? I went to the market, that's why I came here.
I'm glad that you're here. Actually, I have a problem.
Don't hesitate to tell me everything, my friend. I'm willing to help you.
I want to save my money for my daughter's baby, and I want to save this in separate paper.
Don't worry, I have a solution to your problem. I suggest that you can inquire to my bank. You can deposit your money there.
But how I can do that?
How much money that you want to deposit?
I think 5K, is that possible?
Yes, that's possible. And you know, warranty, we have 7% annual interest there.
How much that money I save in 6 years? I hope that it will help my daughter's party.
Oh, that's what Yana need to know using an ordinary annuity.
If Rajay deposits a 5,000 at the end of each year for 6 years, an effective annual interest rate of 7%, what is the total amount available upon the deposit 6th payment?
So, we're going to use the formula of future value in ordinary annuity, wherein A is the payment, I stands for interest, N is equal to period of time, F for future worth of money. The formula of future value is future value is equal to annuity times the quantity of 1 plus interest rate raised to n minus 1 all over interest rate. So the given is A is 5,000, N is equal to 6 years, and the interest is 7% or 0.07. We're going to find the future worth of money. First, we're going to simplify the given. 5,000 times the quantity of 1 plus 0.07 raised to 6 minus 1 all over 0.07. Using the calculator,
So the total amount available upon the deposit of the sixth payment is 35,766.45.
Thank you for helping me, my friend. Always welcome, my friend. Anyways, I need to go home. See you around. Sure. See you around and take care. Okay.
Our lesson for today in mathematics investment is about ordinary annuity. Ordinary annuity. Annuity is an annuity in which the cash flows or payments occur at the end of period. This is the ordinary annuity formula, which to find the future value of ordinary annuity is FB is equal to P times quantity of 1 plus R raised to N minus 1 over R. For finding the present value will be P times 1 minus 1 plus R quantity raised to negative N over R. So this is the example. So Robert was getting 100,000 pesos for 5 years every year at an interest rate of 5%. Find the future value using the ordinary annuity formula at the end of 5 years. So this given is the principal will be 100,000 pesos. The interest rate will be 5% or 0.05 and the N which is 5 years. So using our ordinary annuity formula, so find the, the future value. So 100,000 times 1 plus 0.05 quantity raised to 5 minus 1 over 0.05. So 100,000 times 5.526 which is equal to 552,600 pesos. This is the future value of Robert. So next is topic it will be finding the periodic payment. So remember the keywords. So J is equal is the nominal interest rate. So M number of conversion per year. So T is time, period or term of the loan or investment. N will be number of payments in the annuity. R is size of each annuity payment. And I interest rate per compounding period. So the formula will be R is equal to S sub n times I over 1 plus I quantity raised to n minus 1. So let's try an example. Example number 1. To accumulate 550,550 pesos, Dang needs to place equal deposits at the end of every 6 months in the fund which earns 20% compounded quarterly. If she will deposit the same amount in 4 years, how large should each deposit be? So given, so S of n will be 550,550 pesos. So the J is equal to 20% or the 0.20 which is the interest. So M is equal to 4 which compounded quarterly siya. So 4 years will be the time and the N. So determine the N. So M times T. So 4 times 4 is equal to 16. So to determine the interest rate, so the J over M, so which J is the rate and the M is the period. So 0.20 divided by 4 will be 0.05. So to get the amount of finding the periodic payment, so this is our formula. So R is equal to 550,550 times 0.05 over 1 plus 0.05 raised to 16 minus 1. So will be 27,527.5 over 1.05 raised to 16 minus 1 will be 27,527.5 over 2.18287458 minus 1. So 27,527.5 over 1.18287458. So the formula will be S sub n times I over 1 plus I raised to n.
So let's proceed to finding the number of payments. Calculate the number of payments by giving a uniform amount, interest rate, number of years, period, and future value. So here's the formula, where n equals log quantity of fi over a plus 1, all over log quantity of 1 plus I. Let's proceed to the example. Rowan makes monthly deposits of 2,500 in a bank which pays 9% converted monthly until he accumulates 70,000 in his account. How many regular deposits should he make? So this is the given. A equals 2,500, J equals 9% or 0.09, M equals 12, I is missing, F equals 70,000, and N is missing. To calculate for the value of I, we need to divide J and M, which result to 0.0075. In the example, we have to find for the number of regular deposits of Rowan. So using the formula, substitute to the values is log 70,000 times 0.0075 divided by 2,500 plus 1 all over log 1 plus 0.0075. The resulting value of the quantity is 1.21 and the other is 1.0075. The resulting of log 1.21 is 0.082785 and the result of log 1.0075 is 0.003245, and so our n is equals to 25.51 number of regular deposit by Rowan.
Okay, this is the continuation report of Mr. Romano in finding the numbers of payment. Example number 2. If Francis deposits today at 200,000 pesos in a bank which pays at interest at 12% converted quarterly, he wishes to make 30,000 quarterly withdrawals from his account after starting 3 months after the deposit dates. So, how many regular withdrawals of 30,000 can he have? Okay, by finding the numbers of payment of an ordinary annuity by calculating the future value, we need to use this formula, which is n is equal to log the quantity I minus pi all over a all over negative log the quantity 1 plus I. So the given fee is equal to 200,000 because it is deposited today. And J is equal to 12% or 0.12. And M is equal to 4. 1 is equal to 0.3. And A is equal to 30,000. So we have to find the value
of the regular withdrawal or number of payments of an ordinary annuity. So using the formula, we need to substitute the value, which is log the quantity 1 minus 200,000, which is P, the quantity 0.3, which is the I, over 30,000, which is the A, all over negative log the quantity 1 plus 0.03, which is I. So the result of substituting the value of the given formula is log 0.8 all over negative log 1.03. And the result of log 0.8 is equal to negative 0.099691 all over negative 0.012837. So the N is equal to 7.55, which is the number of payments of an ordinary annuity. Thank you very much. Good day.